Hello. I'm happy to have a chance to talk with you today. We had a bit of a run from our lunch earlier, so it's nice to see everyone regrouped from our side, and our apologies for being a little bit late here. We've been having some meetings over the past, 2 years or so, discussing an idea of what became termed as computational social science. The original name, is it allowed to share that, or was the Institute for Awesomeness, which was a bit more inspirational, perhaps, in its poetry. And I think probably what people are talking about now that this term is out there is a great challenge, and it's a challenge for the reasons which Sandra is pointing to, because it brings in so many different disciplines to look at problems which are very pressing and need to be addressed, and social science should have something to say about that. We are thinking about that in a few ways, and I think Duncan started off talking about the issues of problem solving, which had a bit of a discussion earlier on. And in the spirit of this being a small audience, having this dialogue continue through the afternoon is probably helpful. And I think problem solving is the right thing. It's what people want is fundamentally to have some impact. What many people want is to have some impact, positive impact, from the research onto the world. And sometimes it maybe is a little bit easier for social scientists to think about that issue than it is to think about solving problems directly. But this is not going to be helpful. This works. Sorry, I should have. I hope there's nothing embarrassing which is going to flash on. It's a little easier to think about in terms of social impact than it is in terms of problem solving directly. I want to talk about something very quickly on forensic ethics. If I had to choose something I want to talk at length by, it would have been this topic. But then I want to go back to something which I know has been very much discussed in our group, having to deal with productivity and organizations itself. And a little bit of touches back upon some of the language which people have been using, and that has to do with the words of causality and mechanism, and how a social science might bring some ways to enrich that, which would be useful for us to discuss. We did a study on, I know some of you have seen this, on the question of whether or not there is bias in economics. The truth of the matter is we could have done this in any social science. The only difference between social scientists who are economics is that there are more Republicans in economics than there are those in sociology. I think using the California data, there's only, I think it's 1 out of 49 sociologists is a Republican, whereas quite low for the area of, I think for economics, it's 1 out of 3. So you get the variance which is important about it, which is more important. So one of the things we're looking here is to simply ask the question, if we're going to do things looking at impact and making knowledge more useful, it's just kind of revealing people's biases overall in this. And this has to do with forensics. This is now big in economics, it's big in accounting, it's moving very rapidly. It uses a lot of the tools which all of you work with. This gives you a sense of the data set. The FEC means it's a federal electoral campaign contribution, where you can code people for ground truth, for being left or right. And then we use this to get a score on those we knew to be Republican or Democrat, and then to predict what others, people who we don't have any FEC contribution on, what they actually might be their politics. So I know this is well known to all of you. I stripped out some pictures. I'm just going to show you one picture to make this sense. I see Matt smiling here a little bit on this. Not everyone in economics likes this, by the way. It's not always that popular to talk about this, but it is relevant to say if you're going to be, who's going to be solving the problems, who are the technocrats you're going to rely upon, how unbiased they actually are. This is Milton Friedman. He actually looks like a very nice fellow here. He's much maligned. And over here is Christine Romer. I guess she was at Berkeley before, and also a person who's generally liked. So this is not a personal issues. The results provide no support for the hypothesis that tax cuts restrain government spending. Indeed, the point estimates suggest that tax cuts increase spending. So who do you think might have said that one? So Romer would be that one. Now, it's kind of interesting that if I ask you, conditioned on the name of the author, what do you think is the person who actually gave the quote? The only information, you had other information on this, but probably we have some reading whether this person is left or right, and we use that in making an estimate on what they actually do. I think the cute thing what we did was saying, does it actually matter to the policy estimates? This is not an amazing line over here, but this looks at their whether they're left or right, and these are elasticities which we had lined up correctly. So these are the actual estimates coming out of regression. It could have been tax policy, or could have been on minimum wage, various policies that you looked at. It says, does it actually matter for me to know whether you're left or right on forecasting your empirical estimates? It's not a beautifully strong relationship, but it does have enough there for certain fields, particularly for tax policy. It's actually significant as well. Now, I use the word significant. Some of you may have been quite involved in p-hacking discussions over the past few years. It's become a big thing. I know, Jazz, maybe you've been part of this as well. Something we did a little bit here. I'm not sure. It's funny when we report this stuff whether you should be reporting significance levels for the differences between these two lines or not. So we don't do that here. But this is, the p-values. This is the share of p-values. And this comes out of people whose politics are in the middle. And these are the extremes of the politics over here. And there's a slight little, we get around that 0.05, there's a little bit of a diversion. The people who are highly motivated in politics are more likely to perhaps p-hack than those which are not. I'm very happy to say this is not a left-right sort of horse race here. Although I will perhaps say on the side, on this particular one, it was a little bit more of a problem for the right than it was for the left, but probably not 0.05 significant. So that was one study we did on this, which is of some interest in using these methods. And I think forensic ethics is actually important for ways to think about changing the world, because you have to also think about who are going to be the technocrats, what are they going to be giving as advice, what kinds of bias will be brought into it, and can we detect it? Because what we really want as a minimum is things to be transparent and people to be accountable. I mean, that's probably what we want to look for, as opposed to who's right or wrong on these ahead of time. We did something on Panama tax havens as well. I'll show this real quickly. You probably saw the Panama tax haven stuff came out. We happen to have some older data on this. If you never knew what a tax haven was before, you know what it is now. Basically, you're not regulated. You don't pay. No one knows you got the account. You just pay a fee to the bank for how it works. They charge only $300 to the government, unless someone leaks all the information to the public, which happened in this case. And then you can take the gravity equation, which is a nice physics-derived equation, take the residuals off that, and using a minimum spanning tree, look at the various hubs. These are the hubs which have too much going on. This is not for this is for tax havens. This is really on this. I chose this to be more sensational. This is on migration patterns, so you can kind of see the pattern into particularly Europe of what countries are being fed to from outside of Europe as entry points into Europe itself. Not an amazing use of analytics on this, but still quite interesting. If you know Europe, that these are quite critical points, and also Lithuania comes up as being important, particularly for those who are from the former Russian Soviet orbit. So, just an example of forensic ethics and how it can be used in this line of work. And I think it's an area where it's reflecting on what can be contributed from the social sciences using a pretty standard toolkit with a little bit of analytics added to it. Mm-hmm.
So I'm not sure how to interpret this. So what is the conclusion from that figure?
This is just a descriptive map of where the flows of immigrants are coming from which countries, and through which ports. What are the main points of entry into that into Europe, for example, the UK or elsewhere. It's purely descriptive.
Well, these are people.
These are people.
Okay.
Right. But we do this also for trade. We do this for investment. It's more standard, but you can do this for migration as well. Right? This is the residual coming off a gravity equation now applied to immigration.
I sort of lost track. So what does that have to do with tax havens?
Yeah, I guess it's the, I don't blame you. It's the earlier ones talked about the role of tax havens. They don't play much of a role here, except that there seems to be some migration from the UK. So tax havens is not the key thing here. It has to do more with just the geographic pattern on that. Let's turn to the productivity puzzle, which I think is, which I want to spend more time on. And I wanted to do this to come to something which is a little tricky to present, because I'm going to present a simulation. Usually I do simulations with data. I use the data to simulate from that. This is going to be a pure simulation. I'm doing this a little in the spirit of something which Duncan said very quickly earlier on, and that is kind of one of the missing elements of knowledge, if you wish, despite the incentives for getting it correct, has to do with making organizations more productive, or making them work actually better. And you know, I might, since I do work in a business school as well as elsewhere, you might think I would take offense by that comment, and I do. But the truth of the matter is, there's a lot of truth to that, and you'd think there would be more consensus on what's happening. And I want to give you what my view is illustrated through a simulation. It's a very simple simulation, but just to illustrate what I think why we get it wrong so often. It has to do through the concepts of homophily, which you heard earlier, and that also of cohesion. Paul McDuffie ran the MIT auto study, which became the global auto study. And this Fritz Pills at University of Pittsburgh, a guy named Charles Reagan, who I talked to Jazz earlier on this. So I think he's an amazing guy, as long as you don't take his work as causal, but more as categories being created. And they've been doing a lot of work, John Paul in particular, on productivity data here. This is productivity data. This is best, average, and worst. And what you can see is that there's a lot of variation across, not companies, but across plants. This has always been one of the great puzzles in productivity studies. Is not terribly surprising. It was less surprising that productivity differs across firms, or they differ across countries. But why should they actually differ across plants themselves? That's always been a great puzzle. You think if you own it, you think you'd have the right to transfer the knowledge. It's not a knowledge problem. You own the knowledge. It's not property rights issues which are involved. So why don't you get this best practices everywhere emerging in the world? And this has been an area of a lot of study, and I think we're still at a fairly primitive level of understanding of what these issues are. Everyone wants to know, why don't you pick up best practices? Kind of in the back of what Matt was talking about earlier was the same issue. Why don't people automatically pick up microfinance? Could be an information problem, or it could be some other issue which is involved. Why don't people use fertilizers, or why don't people change the way they do their farming? Well, you see this even in very modern, advanced technology. This is 1989 data. You can see that it was particularly bad in the new emerging markets. Japan was particularly low, but this changes pretty rapidly over a period of time. This is 10 years later, and what you see is that you look at lower labor hours, not breaking it down by region, you can see that the mean fell quite a bit, for free, if you wish. It's like everyone kind of learned what was happening in the environment. So the plants got more productive itself. And the end of these samples are about 60, which shows you some of the problems of actually doing this research, is getting the right number. But it also points to something else which I think is really important. All this work was done with cooperation with people who are doing ethnography as well. Now, there may be better ways to do ethnography these days, like we can talk about that maybe this time, but in this multidisciplinary world, you still know people who actually know the ground very well and can get the data. So in the books which Duncan put up earlier, Seeing Like a State, I kind of sympathize with that. You kind of have to know the circumstances of where the data comes from, and often you need a team for that. This is another way to see this in terms of the differences. And you can see that Japan is still ahead. This is Japan and North America. But the U.S. is not far behind at this time. Lower is better in this world. It's like golf. Lower is better than high. And Europe also has picked up pretty well, but still is lagging in a number of their manufacturing plants. So it's been a general shift, but a lot of things have gotten better. What's interesting is that if you actually break it down into practices, and this is how it usually works in productivity studies, the way things are done, if you break down the practices still vary a lot. Now, for example, one of the most important things is teams. Team production is really important, for example, in Europe. Really hugely important. If you look at a German production line, teams is the way it's done. In the US, it's about 25%. So it's huge variation around this. So you would think that there'd be convergence in practices to create the same level of productivity, but that's not what you find. You find actually very often a discrete number, a finite number of different ways of organizing these areas into coherent bundles. So what's going on? And I want to cite to you just a study which I think Matt knows has always puzzled me. It's a study done by colleagues primarily at Stanford, if not all at Stanford, by Nick Bloom and other folks, published in the Quarterly Journal of Economics, which is a well-known journal, which they did a $1.8 million study, just to give a sight of how expensive this research actually can be, looking at, I think, 20 plants, some which were treated by a consultant, some which were not treated by a consultant. You hear the treatment aspects which are being used. And they had 39 practices which they were looking. Now, 2 to the 39 is a really big number, right? So you think about all the ways you can combine these practices just on an off-on sort of basis, that's really huge. And the number of plants, I said to you, was small, but we've only tackled a small number. We only have observations on a small amount of that particular space, which you have to look at. So it's giving a sense of how big the problem actually can be. Now I'm exaggerating, because probably we don't need 39, we need something less. But what's interesting, even though that John Roberts was involved in this, he's an amazing economist and it made tremendous contributions in the areas of complementarities, actually the amount of, they didn't even do it in a sense of complements, interactions, they did it just in the sense of adding things up. This is a hard problem. So if you want to look for hard problems to solve, this is a hard problem to solve. It's extremely important in productivity, whether it's health services or whether it's car production. It's really hard to do this correctly, and it involves a lot of the techniques which we know comes out of machine learning and elsewhere, just to make some progress on it. I don't have a lot of time. I want to do this kind of quickly to give you a sense of what I'm doing, which is just as well, and then I'll show you what I think the actual benefit of this is. When you're faced with a lot of data, potentially, you have problems. The truth of the matter is that we have very little data on organizations. Now, I'm not going to go through the history of organization theory, the people who can do that better than me, but I will say there was a time when you thought of organizations as being hierarchies, particularly, coming out of the military tradition. There was a general, there was staff, it was divided up in various ways. This is called the formal organization. By and large, what's taught in business schools these days in organization theory doesn't rely upon that anymore. I'm not sure students even walk out knowing what an organizational chart looks like very much. That's why when you put up a chart of a business group, for example, even faculty kind of step back and say, oh, that's what it looks like to actually have cross-ownership in the world. People don't see that anymore the way they did before. Instead, what's often taught is social networks, which might overlap with formal networks or may not, but that's generally the approach taken. And one of the people who do this is a guy named, particularly, is Ron Burt, and he's made a lot of major contributions in this spirit. It's been very influential. Usually cross-sectional analysis, looking at, for example, what effect does clusters of people have upon some outcomes, such as promotion of individuals, such as gender equality, etc. But that's been the spirit of things which have been done. I don't think I'm wrong in saying this, and I don't wish to embarrass anyone. I think this changed dramatically about 15 years ago when people started looking more at dynamics. And a lot of that came from thinking about networks as graphs, and it came from places outside of the social sciences itself, and it's been very influential on this. But somehow, we have not made a lot of progress in getting down to these issues itself. And some of the contradictions, there's been some contradictions and also some disappointments. Let me just give you an example of this. One is, and I like this paper. I know this was a frustration for Duncan. This is a paper which looked at different topologies. I think it was a public goods game which was being played, and said, does it matter how you organize yourself? And you have to remember, for those of you who come from Bell Labs, Bavalis did this, 60 years ago, looking at group structure impacts upon communication flows and elsewhere. But in terms of these games, did not find a huge amount of difference. A lot of other things which are amazing to read in that article. But one of the important things is that structure itself did not determine the way people played this particular game. The results were primarily the same across the various games, and this is what this graph here actually shows. Over rounds, they behave very similarly. There's another. This is more of a simulation outright. That was an experiment this is by Centola, which says looking at different network structures, varying them in various kinds of ways, found out that there was not much differences in general. There's lots of language here. One of the things he says in this space is, and it seems to work only in a very limited parameter space. Now, think about this problem. Think about being the head of an organization, and you have to know how much structure to put in, how much team structure to put in, how much of a socialization training you have to put in. And someone says to you, but by the way, it only works over a certain parameter space. You get outside that space, it's not going to work. That, again, is a hard problem. It says you really, even if you know you should use teams, how much you should actually be using it itself. And we know a lot from the work which was cited to you earlier. This matters for things like diffusion. That people, Twitter data, for example, on do people mobilize over the giving for Biafra? The answer was, by and large, no. They all signed up that they thought Biafra starvation was horrible, but they did not organize for actually doing it. So what is missing in this topology, which is really important? And what's missing probably is that there is a degree of emotional commitment to these networks, such that when you go into an Indian village, it matters to know whether or not you know the person next to you or not, or you can identify that particular person. It matters to have that kind of knowledge. Or it could be that when you form a social network, you all heard people talk throughout this morning about this. It matters if it's homophily, which is whether we're similar, on what dimension we're similar, whether we're academics, same field, come from the same country. There's a aspects of homophily or a degree of cohesion, which can be understood as a team. It's probably the same thing true also for mobilizing a large corporation, or mobilizing even small firms. You can form any sort of typology you want. You can read to something saying Ron Burt's correct. You create these structural holes with the centrality and just those two people commuting back and forth, but it may not work. And it won't work because it has no meaning for those people who are actually engaged in that process. Mechanical Turk experiments are great, and we all know this, but for some things it's not going to work as well because the topology does not have meaning to the people who are engaged in it. You know, I know this is obvious to all of us, but actually it's very important to think about what this means. Now, my challenge was to take this and to think about, could we actually stuck this into a simulation box? And it's so weird after what I just told you, right? I should be going the other direction. But can we actually trick a simulation to make it look this way? And here we want to find is the sweet spot. This is what I meant by a limited parameter space, a certain sweet spot where things are correct and generate a good topology, which you want to look at. And I also say they're fragile. I mean, organizations fail all the time. These plants failed. Many were sold at the same time. So they are fragile organizations. And it's really tough as a manager or as a member of a president of a university or whatever you want to look at to keep this all going because of this very limited space where things actually work very well. And then I'll say something about scaling if there's time permitting. And I don't think I have that much time. I'm not going to talk about Mansky. This actually is a Mansky problem on this. I'm going to say to you, this is what's nice about a simulation, is that you can do a stage one. I call this a Dixit-like simulation. If anyone in economics, it usually is a stage one. You invest, and stage two, you play the game. The same thing with networks. Matt talks about this a lot in his textbook. First, you form the network, and then afterwards, something happens, which you actually are looking at. We're doing this through an agent-based model. My co-authors on this is Jae-Suk Yang, who's a physics out of KAIST, now running a social science computational lab at KAIST, and Jerry Kim, is my colleague at Columbia. Stage one, you take the social preferences and you generate that first, trying to see whether or not we can put meaning into a simulation, of a formation of a network based upon preferences. The preferences are homophily and cohesion. I call them, homophily to me is socialization. That's what a manager has to do, has to socialize. And cohesion is teams. So it's kind of, I mean, it seems silly, but I'm trying to find what are the actual organizational constructs they're representing. So they're not so abstract. They actually say, well, this is why it might be meaningful to an organization itself. It's teams and socialization. We know these are important structures to it. And then we do this kind of knowledge transfer task. It's very simple to do this, almost embarrassingly simple. This I'll skip. This is Blankfein of Goldman Sachs. You guys are from the West Coast. You probably don't even know who he is. Because all the way over into New York City. But we know who he is, especially if you come from Columbia University, have a business school. And these are the teams which are being formed over here. Actually, it matters how you compose these teams. I'm not getting into how you choose them. I'm letting this happen naturally. The way I do it in this one here is I assume there's a person 1, person 2. They have 4 traits. They can be 1 zeros. And homophily is measuring how many common traits do you have the same value on. So that's the homophily measure itself. This is an example. Homophily is infinity. You've got this perfect matching over here. When it's 0, you've got no matching at all between them. And then when you have intermediate, you have some which are matched and some which are standing out alone. So it's in between the two of them. The other one and this forms, by the way, at these various values, something which is really nasty, which is a very modular structure, which has very, very low diversity exchange possibilities. This would be a bad thing, because how can you exchange between the structures themselves? Over here is random. Everyone's connected, so it has been no particular structure whatsoever. And the one in between is probably going to be something which is closer to the sweet spot, which is what we're actually looking for. Cohesion is teams. These are friends of friends, usually forming triangles of some sort. And they end up and these are the values which you take. Alpha is 0. Here's alpha is infinity, no triangles whatsoever. And then we have something in between. And you can see the network structures which are formed random. You don't see too many triangles going on. When it's very cohesive, you find a lot of triangle structures here. And over here, you find something in between. This is very close to a small world, because in a small world, you always face this problem of things breaking up. And this actually fragments the network as well. These are just two aspects which we chose. We could have chosen other ones. These are the ones we chose to actually work with in this story. Now, what do? I don't have time to do all this very well, so I want you to take my word for this, that we kind of do this correctly, okay? And I'll post this up. And some of this stuff comes, I'm trying to think how much, this here comes from a great book and a thesis, which is straight from Solaria out of Duncan Watts. I know I embarrassed him, on this, but this actually was a great idea, which was left sitting there. And I'm happy to pluck it up and make it work for this one here. And homophily maybe came up a little bit later. I'm not sure why that happened, but I can't seem to get in. I was at the airport. I can't seem to get the airport off my screen here. So what's interesting here is that we're going to vary H, homophily, or we vary alpha, these two things, correct? And then we're going to look at we're taking a small world one here now, we don't have to do this, but I thought this might be fitting, with length and clustering. So you all know those statistics. And what's interesting is you get around certain values. I won't say this with hesitation. You get some property of emergence coming on. Now, I think something we haven't talked about, maybe we don't like that very much, but there's something, one of the reasons we get excited by topologies is that there's a qualitative change in things, which means that there is this parameter space not only matters in that sweet spot, it begins to behave very differently as well. So all of a sudden you get things moving towards shorter lengths or higher clustering values, and it happens in both of these things. So when you plot it out in a small world ratio, which is clustering over length, you can actually plot out that area, and just look how narrow that space is over there. Now, I have no natural metric. I have no data here. I don't know if this is over here is totally, too far away to be interesting or not. But it makes my point that it's over a very small space, okay, on these parameter estimates. And finally, we look at complementarity, which just means do these things work together very well, which is kind of a Roberts thing. And we find out that they have a very small complementarity value. We take kind of the cross partial here to show how that works. But that's not a major result in the paper. This is stage one. We create a topology. We vary by varying the homophily and the alphas. We identify its sweet spot in the simulation, and then we actually move to look at a very simple sort of transfer of knowledge on this. So here we use something which comes out of biology. It's the fitness thing. We randomly assign fitness values to these nodes. This is not a regular graph. This is not like an NK graph for those people who follow that stuff. That is sometimes used in the organizational theory literature. The mechanism of assigning fitness this just simply means we assign randomly these values to these 0, 1s here. I think we have here we just chose 4 as an example, and we get a estimated fitness of 0.45. Okay? And then what we're going to do is we assign it to each one of the graphs, and then for these graphs we're going to ask how quickly is knowledge transferred before you get to a steady state. This is the pure structural model. It's very, very silly. Over here you got one which is a little bit different. This is 0.07. That's got 0.08. Who are you going to learn from? You're going to learn from the one next to you. But you're just choosing on looking to your nearest neighbor. The only thing we're asking here, does the topology matter to the transfer itself in some way? And then we do this by kind of running this race. This is kind of the Markov steps until you get some sort of steady state. And we take the max small world value. That's that little space we saw earlier, and we find out that actually performs pretty well. But random does very well as well. And it's not surprising that random does well, because random is what always achieves very short path lengths in these models. So things are mixed very quickly. But you have to ask yourself the question: what does it mean to have a random organization? And it's not particularly it's kind of an end case, but it gives us some insight into what actually is occurring, what actually drives the value of these structures. We do one more thing on this. We looked at homophily. Why homophily is bad because homophily reduces diversity. Diversity is so important to these simulations of organizations, and probably to organizations in general. And cohesion fragments them, so they don't do well by themselves. They always do well in terms of some mixture of the two. We look at the final one is on the social one. Neighbors' traits are similar to focal nodes' traits, or neighbors are similar to the focal neighbors on this. So you can borrow from those who are most similar to you. It seems to me silly to say once you form the stage 1 topology, there's no longer any effect of homophily or cohesion on what people actually do, as if you turn off. This is actually the Mansky problem a little bit. This influence of the structure, which has happened before. The structure's been formed, but how can you can't just turn off the homophily. That's still going on as well. You're trying to sort through these actual two things. So we run this one. Small world does much better when you have a little bit of social going on. Okay. Now, I'm going to make one last observation. I'll stop. I want to say something. It's not as if small world is the best thing to run. Actually, the other ones you can choose which actually do better. It's not like an Axelrod tit-for-tat sort of contest here, which is this one. I just chose something which we're all familiar with to make the points more clear to us. The social mechanism runs this way. You can see a very minor graphical model. Forgive me, Michael, for saying that. And you can see how that might have different causal aspects to it as well. Okay? The last thing we did is look at size and sociality. I felt this was kind of interesting. As organizations get larger, what happens to their performance? And how do you maintain high performance as organizations get larger? How do you scale up an organization itself? And maybe this is not surprising. If it's just looking at the small world aspects, you can see that for homophily and for alpha, in both cases, as you move to larger and larger organization sizes, that you have to have more homophily. You have to have more socialization. Kind of makes sense. I'm not sure why that came out as a result on that. You know, I was trying to get that off this morning, but I did not succeed. You were thinking a room of computer scientists. I might have asked for some help on this. You know, and then also on the areas of alpha, you get some effects as well in terms of you have more. Larger sizes requires more cohesion on this as well. And also for performance, remember stage 1, stage 2, that was stage 1. Stage 2, you get better performance, but it requires higher levels of homophily in order to do that. That means that the CEO, wherever it is, has to think even more carefully about socialization and pulling these people together actually to work together in their thing. I'm not going to talk about causality. I'll just conclude. We're trying to build an assimilation why the social precedes the structural, how that actually works. Kind of capture that a little bit in the network, trying to say there's a sweet spot. That's why it's so difficult actually to organize these organizations. We identified a sweet spot to make it work, and there's issues in terms of the limited parameter space, which I think is a nice metaphor for why it's so hard actually to lead successful organizations. Okay, thanks very much.